Hello and welcome to yet another video of Cornerstones of Math, and welcome to yet another South Korean college Scholastic ability test video, which is the test that high school seniors take before they apply for the college. Today's problem is as follows. As shown in the figure, three cylinders with the same radius of square root of 3 and different heights lie on plane alpha, circumscribing each other. Centers of the bases of three cylinders that are not on plane alpha are P, Q, and R. Triangle QPR is an isosceles triangle, and the magnitude of the angle formed by plane QPR and plane alpha is 60 degrees. If the heights of the three cylinders are 8a and b respectively, where 8 is the smallest number and b is the largest number, find the value of a plus b. So if we quickly recap the given info, these base radii are all square root of 3, and we have these heights 8a and b. This triangle QPR right here is an isosceles triangle, and these two planes form an angle of 60 degrees. Now let us solve the problem. Here, instead of plane alpha, let us think on a new plane called alpha prime, which is the plane that contains point P and is parallel to the original plane alpha. Then, we can construct the projections of points Q and R onto this new plane alpha prime, which we will call Q prime and R prime respectively. Now, let us think about this newly formed triangle PQ'R' on plane alpha prime. Since three cylinders circumscribe each other, triangle PQ'R' is an equilateral triangle. Since all circles have the same radius, square root of 3, the side length of this equilateral triangle is 2 times square root of 3, which gives the area square root of 3 over 4 times the square of the side length, so 2 square root of 3 square, hence 3 square root of 3. Next, let's use the given condition that plane QPR and plane alpha, hence alpha prime, forms 60 degrees angle. This is the part where we use this useful formula for a projected area. If we have the original shape having area A, and this shape is projected onto the secondary plane, which forms angle theta to the original plane, then the projected area AP is given as A times cosine theta. In our case, theta is 60 degrees, so the projected area PQ'R' is equal to the original area PQR times cosine 60 degrees, and the projected area is 3 square root of 3, so this equals 1/2 times triangle PQR, which gives the area of triangle PQR 6 square root of 3. So now with this area obtained, let us take a closer look on this part. We need to do more detailed work right here, so let's enlarge this part, which gives this figure. This base plane PQ'R' is plane alpha prime, and the figure also shows point R double prime, which is the foot of perpendicular from point Q to line segment RR prime. Here we have already obtained that length PQ' and Q'R' and PR' are all 2 square root of 3, the side length of an equilateral triangle. The heights of three cylinders are 8a and b, which gives length QQ' as a minus 8, hence R'' is also a minus 8, and RR' is b minus 8, and RR' is b minus a. we want to use the given condition that triangle QPR is an isosceles triangle. This means that at least one of the following is true. PQ equals PR, PR equals QR, or PQ equals QR. If PQ equals PR, this means that QQ prime equals RR prime. That is, if this length equals this length, then this length equals this length, since we already know that this length equals this length. That is, we have A minus 8 equals B minus 8. However, since B is greater than A, this is impossible. If PR equals QR, then we have RR prime equals RR double prime. That is, if this length equals this length, then this length equals this length. Straight up from the figure, this looks impossible, but if you want to do it algebraically, this means that B minus 8 equals B minus A, hence 8 equals A, which is impossible because A must be greater than 8. Therefore, the only case remaining is PQ equals QR. This means that QQ prime equals RR double prime. That is, because this length equals this length, we have this length equals this length. So we have A minus 8 equals B minus A, hence B equals 2A minus 8, which is possible. We want to use the fact that the area of triangle PQR is 6 square root of 3, which was obtained from the projected area formula, the one with cosine theta. In order to calculate this area by another method, we need to find the expressions for side length of triangle PQR. Using the Pythagorean theorem, length PQ squared, hence QR squared, is given by 2 square root of 3 squared plus A minus 8 squared, which gives A squared minus 16A plus 76. So length PQ is square root of that. And length PR squared is given by 2 square root of 3 squared plus B minus 8 squared. And using B equals 2A minus 8, this B minus 8 squared becomes 2A minus 16 squared. So by taking out 2, we have 2 squared, so 4 times A minus 8 squared. And this part is 12, so we can take out 4 here, which gives 3 here, then plus A minus 8 squared. So 4 times A squared minus 16A plus 67. Therefore, by taking square roots, length PR is given by 2 times square root of A squared minus 16A plus 67. So we have this picture. Isosceles triangle PQR, where length PQ and QR are each given by square root of A squared minus 16A plus 76. And if we split length PR in half, each segment has the length square root of A squared minus 16A plus 67. To calculate the area of this triangle, let us find this height h. Notice that h squared is equal to A squared minus 16A plus 76 minus A squared minus 16A plus 67, which gives 76 minus 67, hence 9, which gives h equals 3. Therefore, using that the area of triangle PQR is 6 square root of 3, we have 1/2 times the base length PR, so 2 times square root of A squared minus 16A plus 67 times the height 3 equals 6 square root of 3, which gives square root of A squared minus 16A plus 67 equals 2 square root of 3. So a squared minus 16a plus 67 equals 12. So a squared minus 16a plus 55 equals 0, which can be factored into a minus 5 times a minus 11 equals 0. And a must be greater than 8, hence a equals 11. And b equals 2a minus 8, which gives 14. We want to find the value of a plus b, which is equal to 11 plus 14, hence 25. And this is the answer. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.